Hello everyone, this is John Hashmet and welcome to Physics Simply. In this video I will be solving the paper 2 exam for February-March 2022. So let's get started. Question 1 says a student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. He repeats the experiment 3 more times. The readings are shown. What is the average period of the pendulum? That is the time of one oscillation. So first we get the average of the 20 oscillations, 17.6 plus 19.8 plus 17.6 plus 18.6. Then we divide that by the number of measurements, which is 4. Then after that we have to divide by 20, since it's the time for 20 oscillations and we want the time for one oscillation. This gives an answer of 0.92, so the answer is B. Question 2 says a tennis ball falls from the upstairs window of a house. What can be said about the acceleration of the ball if air resistance is ignored? So it's only moving under gravity. It depends on the density of the ball. No, it does not depend on the density nor the mass. It increases as the ball falls. No, gravity is constant at the surface. It stays the same as the ball falls. Yes, so the answer is D. Question 3 says a car joins a road at a speed of 14 meters per second and accelerates at 4 meters per second squared for 5 seconds. What is the final speed of the car? So we can use the definition of acceleration. It is the change in velocity divided by time, or we can make the final velocity subject. So v equals u plus at. The initial velocity was 14 and the acceleration was 4 multiplied by the time, which is 5. So the answer is 34 meters per second. So the answer is D. Question 4 says the gravitational field strength is 8.8 newtons per kilogram on Venus and 3.8 newtons per kilograms on Mars. An object has a weight of 42 newtons on Venus. So we have the weight and the gravitational field strength. What is the mass and the weight of the object? So first we can calculate the mass as the weight divided by the gravity field strength. So we have 42 divided by 8.8. That gives an approximate answer of 4.773. So it's 4.8 here. Then we need to get the weight on the other planet. So we multiply the answer on the calculator by 3.8, which is the new gravity field strength. That gives an answer of 18.1364. So it's 18. So the answer is A. Question 5 says a student carries out an experiment to find the density of a rock. Which two measurements does the student need to make to determine the density of the rock? So we need the volume of the rock and the mass of the rock. So from here to here, the mass increased and the volume also increased. So we need the increase in volume and the increase in mass. So increase in mass, yes. Increase in volume, yes. Increase in depth, no. Increase in depth, no. Increase in volume. So the answer is A. Question 6 says a car has a mass of 1,500 kilograms. A constant resultant force acts on the car and the car accelerates from 15 meters per second to 20 meters per second in 4 seconds. What is the magnitude of the resultant force? We can calculate it using the equation force equals change in momentum over time, or impulse over time, which is mass multiplied by the change in velocity divided by time. Then we substitute. We have 1,500 kilograms. The final velocity was 20. Initial was 15. Then we divide by the time, which is 4 seconds. That gives an answer of 1,875 newtons. So we can approximate that to 1,900. So the answer is C. Question 7 says a metal wire is loaded up to the limit of proportionality. Which statement is correct? Hooke's law is not obeyed. No. Up to the limit of proportionality, that is the part that obeys Hooke's law. When the load is increased beyond the limit of proportionality, the diameter of the wire will increase. No, it should decrease. It gets thinner before it breaks. When the load is removed, the wire returns to its original length. Yes. Up to the limit of proportionality, there is no change in the shape of the wire. No, the length changes. So the answer is C. Question 8 says a diagram shows a uniform meter rule. Mn pivoted at its midpoint. Two weights W1 and W2 are hung either side of the pivot. The rule remains balanced. Which row is correct? So balanced means there is no resultant force and no resultant moment. So it has no direction, and the resultant force also has no direction, 0 and 0. So the answer is D. Question 9 says, which physical quantity is a vector? Not density, not mass, not temperature. Velocity is a vector quantity which has direction. Question 10 says, a resultant force of 500 newtons acts for 10 seconds on a car of mass 1000 kilograms. This causes the velocity of the car to double. So if the initial velocity was u, the final velocity would be 2u. What is the final velocity of the car? So we can use the equation impulse or force multiplied by time equals mass multiplied by the change in velocity. So 2u minus u, final minus initial. And we can simplify that to 2u minus u is u. So 2mu equals force multiplied by time. So u equals force multiplied by time over 2m. So we have 500 times 10 over 2 times 1000. So the initial velocity was 5 meters per second. So the final velocity is twice that, double that. So the answer is B, 10 meters per second. Question 11 says, a child pushes a toy car along a horizontal surface and then releases it. As the car slows down, what is the main energy transfer? There is no chemical reactions here. From kinetic to gravitational, no, because it was a horizontal surface, no increase in height or decrease. So from kinetic to thermal due to friction, so the answer is D. Question 12 says, at time 0, a cannonball is stationary inside a cannon. The cannonball is then fired from the cannon. At time t equal t, the cannonball moves forward and the cannon moves backwards. What happens to the total kinetic energy and the total momentum of the cannon and the cannonball between time 0 and time t? So for this explosion, the momentum is conserved, so the total momentum remains the same, but there was no kinetic energy at the start because everything was stationary. Then they moved, so there is kinetic energy at the end, so kinetic energy changes, so the answer is B. Question 13 says, in a small hydroelectric power scheme, 800 kilograms of water drops through a vertical height of 2.2 meters. Every second. The electrical output is 10.6 kilowatts. What is the efficiency of the scheme? Efficiency is equal to the output power divided by the input power multiplied by 100 for percentage. So we have here output is 10.6 times 10 to the power of 3 for kilo. Then we divide by the input power, which was some kind of loss in gravitational potential energy. So it's mgh over time, energy over time to get power. 800 kilograms times 9.8 times 2.2, and all that divided by the time, which was 1 every second. Then we multiply that by 100. We get an answer of 61.456. So the approximate answer is 60%. So it's C. Question 14 says, an object is at rest on a horizontal surface. Which equation is used to calculate the pressure that the object exerts? So it's not mass over area, it is weight, force over area, yes. Not mass multiplied by area and not weight multiplied by area, so the answer is B. Question 15 says, smoke particles illuminated by a bright lamp are seen through a microscope. They move about randomly. What causes this motion? Attraction between the smoke particles and the molecules of the air, no. Collisions between the smoke particles, yes, and the air molecules. Evaporation, no. Warming, no. So the answer is B. Question 16 says, ether is a liquid that evaporates easily at room temperature. The rate at which ether evaporates can be increased by bubbling air through it. The diagram shows this process. So air goes in and rises up as bubbles. Students, give 3 suggestions why the rate of evaporation increases when air is bubbled through. Student 1 suggests that the temperature of the ether is decreased. No, decreasing temperature decreases the rate of evaporation. Student 2 suggests that the surface area of the ether is increased. Yes, since the area of the liquid in contact with air increased due to the bubbles having their own surface area. Student 3 suggests that the evaporated molecules are removed at a greater rate. Yes, since technically there is wind. So suggestions 2 and 3 are correct. So the answer is C. Question 17 says some ice is slowly heated and its temperature is measured. A graph is plotted of temperature against time. Which row describes what happens to the thermal energy and to the temperature in section X? In section X, the temperature does not change, so stay the same. And since the general graph shows increase in temperature or heating, so energy is gained by the object, not lost from the object, so gained by the ice. So the answer is B. Question 18 says the diagram shows the apparatus needed for an experiment to determine the specific heat capacity of the material from which an object is made. Which piece of apparatus could be omitted if the purpose of the experiment is to determine the thermal capacity, not the specific thermal capacity? So the equation for thermal capacity, Q equals mc delta theta, and C is the specific heat capacity. For thermal capacity only, Q equals C delta theta, and C is thermal capacity. So the difference between the two equations is a mass, so we can remove the balanced from the apparatus. Question 19 says both boiling and evaporation involve a change in state from liquid to gas. Which row gives the correct difference between boiling and evaporation? For boiling, no bubbles are formed. No, there are bubbles. Occurs at all temperatures. No, at a fixed temperature. Occurs through the liquid. Yes. The temperature falls. No. For evaporation, bubbles are formed. No. Occurs at definite temperature. No. At any temperature. Occurs at the surface. Yes. The temperature remains constant. No, it decreases. So the answer is C. Question 20 says which statement describes thermal conduction in a metal by electrons? Atoms and electrons move freely. No, atoms do not move freely. Atoms and electrons vibrate about their fixed positions. Electrons do not vibrate about fixed positions. Electrons move freely through the metal. Yes. Electrons remain attached to the atoms in metals. No. So the answer is C. Question 21 says a tank contains water. Ripples are produced on the surface of the water. Refraction is observed. What causes the ripples to refract? The cold water in the tank replaces the warm water. No, that's convection. Ripples change speed as they move from deep to shallow water. Yes, that is refraction. That's a change in speed. The ripples hit the wall of the tank. That would cause reflection. The ripples pass through a narrow gap. No, that's diffraction. So the answer is B. Question 22 says the diagram shows a wavefront of a water wave passing through a gap in a barrier. Which change will increase the refraction of the wave as it passes through the gap, so increasing the curvature? That would require the wavelength to be larger than the gap, or the gap narrower than the wavelength, or approximately equal. So increase amplitude does not affect. Increase the width of the gap. No, we need to make it narrower. Reduce the depth of the water. No. Reduce the frequency of the wave. Yes, if you decrease the frequency, the wavelength increases, so it gets greater than the gap width. So the answer is D. Question 23 says the diagrams each show a ray of light from an object O passing through a thin converging lens. The principal focuses in each diagram are labeled F. Which diagrams are correct? So the ray that passes through the optical center passes through undeflected, so 1 is correct. The second one, a ray parallel to the principal axis, should go through the focal point, so 2 is wrong. Diagram 3, we have a ray that passes through the focal point. It should go on the other side parallel to the principal axis, so 3 is correct. So 1 and 3. So the answer is C. Question 24 says the diagram shows a ray of light inside an optical fiber approaching point X. The light is totally reflected within the fiber. The refractive index of the material of the optical fiber is 1.39, which condition ensures that the total internal reflection occurs. So we need the angle of incidence to be greater than the critical angle, and we can calculate the critical angle as the inverse sine of 1 over n, or 1 over refractive index. So we can calculate the critical angle as the inverse sine of 1 over 1.39. That gives an answer of 46 degrees approximately. So the angle of incidence must be greater than 46. So we have here, this is the angle of incidence, Q. So Q must be greater than 46. The closest one is Q greater than 47. So the answer is B. Question 25 says an eclipse of the sun happens when the moon comes between the earth and the sun. Which statement is correct? Infrared radiation from the sun disappears before visible light and ultraviolet radiation. Ultraviolet radiation from the sun disappears before visible light and infrared. Visible light from the sun disappears before ultraviolet radiation and infrared. Infrared radiation, ultraviolet radiation, and visible light all disappear at the same time. Yes, that makes sense because all electromagnetic waves travel at the same speed in space or in vacuum. So the answer is D. Question 26 says the diagram shows air particles in a sound wave. Which row correctly identifies the positions of compression and the position of rarefactions? So V is a compression, W is a rarefaction, X compression, Y rarefaction, Z compression. So for compressions, X correct, Y not correct, V correct, Z is correct. For rarefaction, Y is correct, X is not correct, Z is not correct, V is not correct, so the answer is A. Question 27 says two isolated metal spheres are both negatively charged. The spheres are brought close together but do not touch. Which diagram shows the charge distribution on the spheres? So negative charges are like charges, so like charges repel. So the answer is D. They go far apart. Question 28 says two separate circuits have different power supplies. Both power supplies provide the same magnitude current. So same current means the rate of flow of charge is the same. Power supply P has an electromotive force of 1.5 volts and power supply Q has an EMF of 3 volts. Which statement about Q are correct when compared to P? So Q supplies twice the charge per unit time. No, because it should be the same for same current rate of charge flow. Q supplies twice the energy per unit charge. Yes, since Q has 3 and P has 1.5, that's double. So 2 is correct. Q supplies twice the energy per unit time. Yes, since the same charge passes, but each charge takes twice the energy, so the total energy is twice. So statements 2 and 3 are correct, so the answer is D. Question 29 says the diagram shows a piece of metal resistance wire. Which wire made of the same metal has a smaller resistance? A wire of the same length with a larger diameter? Yes. A wire of the same length with a smaller diameter? No. Smaller diameter increases resistance. A wire of greater length with the same diameter? Greater length increases resistance. Greater length increases resistance. So the answer is A. Question 30 says which labeled component in the circuit shown controls the brightness of lamp X? So we need to change the current. So we need a variable resistor. So it's B and it's also in series with X. So it is the correct choice. Question 31 says a circuit includes a battery, 2 identical resistors, and 5 ammeters P, Q, R, S, and T. Which statement about the readings on the ammeters is not correct? So P has a greater reading than Q. P and Q are the currents going into and out of the battery. They should read the same reading, so it's not greater. So the answer is A. For B, P has greater reading than R. That's correct, since the current from P is divided onto R and S. P has greater reading than S, yes, same as the one before. P has greater reading than T. T and S are the same, and P is greater than S, so it is correct. Question 32 says an electrician sets up a potential divider circuit in a fridge so that when the fridge door is open and light from the room enters the fridge, a warning light turns on. Which component does the electrician need to use in addition to a variable resistor? So for light entering and detecting light, we need a light dependent resistor. So the answer is A. Question 33 is about logic gates, so you can skip that one for the new syllabus. Two NAND gates are joined together as shown. Which single logic gate is equivalent to this combination? So this shape represents the two inputs of an AND gate connected together, so it acts as a NOT gate. So a NOT gate reverses the output of the previous gate, which is an AND. The opposite of an AND gate is an AND gate, so the answer is A. Question 34 says the diagram shows an electric drill and safety guard. The drill requires the logic circuit shown. The circuit must only allow the motor to start when the safety guard is closed. If the safety guard is not closed when the starting switch is on, so that's two conditions: switch on and safety guard on or closed. So we have two conditions. That means that we need an AND gate, always an AND gate if there are two conditions to be fulfilled. Question 35 says two magnets are placed near a current carrying coil. The diagram shows this experimental arrangement and the current direction in the coil. Which statement is correct? Both X and Y are attracted, both X and Y are repelled by the coil. X is attracted, Y repelled, X is repelled, Y is attracted. So we need to know the polarity of this electromagnet. So the current is moving up from behind the coil and moving down in front of the coil. We have to use the right hand grip rule here. So the fingers are curled in the same direction as the current and the field is pointing this way. Means that this point is north and this point is south. So north and north repel, south and south repel. So they both repel. So the answer is B. Question 36 says two circuits are set up as shown. The iron rods are placed close together and are able to move. What happens to the size of the gap at X when the switch S is closed? Does it change? Does it increase due to repulsion? Does it decrease due to attraction? Or does it not change at all? So if we use the right hand grip rule again here, so we have this is a north pole and this is a south because current is going down in front and going up from the back. And the current here is reversed on the right side. So this would be a south pole and this will be a north pole. So north and north repel, so the gap increases in size. So the answer is C. Question 37 says when a current carrying conductor is placed in a magnetic field, it experiences a force. Which statement about this force is correct? Is it parallel to both magnetic field and current? No, it's not parallel to neither of them. So any parallel here is wrong. So the answer is D. It is perpendicular to both the magnetic field and the current. Question 38 says when a beam of alpha particles is incident on a thin metal foil, most of them follow a path represented by the path X, which means most of them pass undeflected. A small number of alpha particles follow the path represented by Y, which is rebounding. So which row correctly describes a conclusion that can be drawn from each of these observations? So the undeflected parts, most of them were undeflected. That means that the atom is mostly empty space. So it did not affect the path of the alpha particles. Some follow the path of Y. That means that they hit something and rebounded. So atoms contain something that repels alpha particles. That makes sense. Yes. Nucleus contains protons and neutrons. You cannot know that from this experiment. So the answer is A. Question 39 says nuclear fusion is a reaction that takes place in stars. Which row describes this reaction? An atomic nucleus splits into two. No, that's fission. This is also fission. Atomic nuclei joined together. Yes, that's fusion. Energy is absorbed or released. It is released in fission and fusion. So the answer is D. Question 40 says when a radioactive isotope is set up close to a count rate of 38,000 counts per second is obtained. The table shows the count rate from the isotope over 3-year period. What is the half-life of the isotope? So for one half-life to pass, we need to divide that by 2. That gives us 19,000 as a reading. So it's in between 26,000 and 17,000. So between 1 year and 2 years. So it is not less than 1 year, more than 1 year, but less than 2 years. Yes, that is the correct choice. So the answer is B. So this was the end of the exam. I hope you enjoyed this video and found it useful to you, and I will see you in another video.